Let's look at trigonometry and how we can find sides. So the example says work out the missing side, and we've got a right angled triangle with 3 angles, and we've also got a side length, and we're trying to work out this missing side length b. So we could use one of our equations here for sine, cos or tan to work out the missing length b. And so if we choose one of the interior angles, let's look at 40 degrees, then in relation to 40 degrees, we're going to mark on each of the sides of the triangle with the opposite, adjacent and hypotenuse. So in this case, for 40 degrees, the opposite side is b, so we'll label that as O. The hypotenuse is always the side that's opposite the right angle, so in this case that's 15 centimeters, so we'll label that as H. And then the side that's left over, or the side that's closest to the angle that isn't the hypotenuse, is the adjacent, so we'll label that as A. If we're interested in the opposite side, the hypotenuse, and we've got an angle of 40 degrees, then we can use sine x equals to the opposite over the hypotenuse, or in other words, so to work out the missing side length here. So we have sine of 40 degrees, which is our angle, which equals to the opposite side, so we'll label that as b, all over the hypotenuse, which is 15. And so we're trying to rearrange for b to solve this equation. We do that by multiplying both sides by 15. So if we multiply both sides by 15, then on the left hand side we have 15 times sine of 40 degrees, which equals to b. And if we put this on a calculator, we should find to 2 decimal places that b equals to 9.64 centimeters, and so our length for b is 9.64 centimeters. We could also have worked out the length of b using the angle 50 degrees instead of 40 degrees. So let's look at the method we would use if we were to use 50 degrees. So the first step again is to label each of the sides of the triangle in terms of the opposite, hypotenuse and adjacent in relation to 50 degrees. So the opposite side is this side here, we'll label that as O. The hypotenuse is always the side that's opposite the right angle, so that's 15 centimeters, we label that as H. And the side that's left over, we label that as the adjacent, or A. So looking at the sides that we're interested in and the values that we have, we're trying to work out B, and we have 15 centimeters. So the 2 sides that we have are the adjacent and the hypotenuse. And so looking at SOHCAHTOA, the equation we need is cos x equals to the adjacent over the hypotenuse. And so we have cos of our angle, which is 50 degrees, which equals to the adjacent, or b, all over the hypotenuse, which in this case is 15. And so solving this for b, we multiply both sides by 15 to get 15 cos 50 degrees, which equals to b. And so if we put this in a calculator, we should find is that we get 9.64 centimeters to 2 decimal places for the value of b. And so we see that we can work out the side length b using either 50 degrees or 40 degrees. We wouldn't be able to use 90 degrees because the opposite side and the hypotenuse are both the same in terms of 90 degrees. And so the only angles we could use are 50 and 40. Let's look at another example. So again, we're trying to work out the missing side. We've got a right angled triangle with 3 interior angles, and we've got a side length, and we're trying to work out one of the other side lengths. So the first thing we do is we label each of the sides with either the opposite, hypotenuse or adjacent in relation to one of these angles. So let's start with 30 degrees and we'll look at 2 different methods. So for 30 degrees, we've got that the opposite is the side A, so we'll label that as O. The hypotenuse is always the side opposite the right angle, so in this case that's this side here, H. And then the adjacent is the side that's left over, we'll label that as capital A. Now that we've labeled each of the sides, we can decide on whether we use SO, KER or TOA. So in this case, we've got the opposite and the adjacent, and so we need to use tan x equals to the opposite over the adjacent. So we have tan of 30 degrees, which equals to the opposite side, which is A, over the adjacent, which is 7. And so we're trying to solve for A, so we multiply both sides by 7 to get 7 tan of 30 degrees, which equals to A. And so putting this in a calculator, we should find that we end up with an answer of 4.04 centimeters to 2 decimal places. And so that's the value of A. We also have worked out the value of A if we started with 60 degrees and then looked at each of the sides in relation to that. So let's look at a second method to work out the value of A. The first step is to label each of the side lengths in relation to 60 degrees. So the opposite side is 7 centimeters, we label that as O. The hypotenuse is always the side opposite the right angle, so that's this side, we label that as H. And the adjacent is the side that's left over, we'll label that as capital A. Look at which side lengths we have and which side lengths we're interested in. So in this case, we've got 7 centimeters, the opposite side, and we're interested in working out A, which is the adjacent. So looking at our equations, we've got the opposite and the adjacent, so we're going to use TOA, or tan x equals to the opposite over the adjacent. And so in this case, we've got tan of 60 degrees, which equals to the opposite side, which is equal to 7, over the adjacent, which is A. Now, we're trying to solve for A, and so what we do is we multiply both sides by A to get rid of this fraction. And so if we do that, we end up with A multiplied by tan of 60 degrees, which equals to 7. And now since we're solving for A, we divide both sides by tan 60 so that we're left with A on its own. Doing that gives us A equals to 7 over tan 60. And so putting this in a calculator, we find that A equals to 4.04 centimeters to 2 decimal places. And so we've worked out the value of A using 2 different methods.